Today we're going to explore a fascinating concept in neuroscience and motor learning called reverse practice. This is the counterintuitive idea that practicing a skill incorrectly on purpose can actually sharpen your mastery. So what exactly is reverse practice? It's a training method where you deliberately introduce errors, distortions, or exaggerations into your practice routine. The core principle is that deliberately practicing mistakes strengthens your brain's error detection circuits. When you expose yourself to errors on purpose, your motor and cognitive systems become better at recognizing and correcting those errors. Think of it this way. By practicing what's wrong, you're building stronger boundaries around what's right. Your brain learns to distinguish correct from incorrect with much greater precision. Let's dive into the neuroscience. How does the brain actually detect and learn from errors? The motor cortex sends commands to execute movements. The cerebellum and basal ganglia act as comparators, constantly monitoring the difference between intended and actual performance. When an error occurs, these regions generate error signals. These signals are crucial because they trigger synaptic plasticity, the brain's ability to reorganize and strengthen connections. There's a fundamental equation that governs how the brain learns from errors. It's called the prediction error equation. Delta equals R minus V. Delta is the prediction error. R is the actual reward or outcome, and V is the predicted or expected value. The larger the prediction error delta, the more the brain updates its internal model. This is why deliberate errors can be so powerful for learning. The weight change delta W equals alpha times delta times X. Alpha is the learning rate, delta is the error, and X is the input signal. This equation is at the heart of reinforcement learning in both artificial neural networks and biological brains. The brain literally rewires itself in proportion to the error it detects. Let me give you a concrete example from sports. Consider basketball free throws. A traditional approach is to practice the correct form repeatedly. Here's a player shooting a normal free throw with correct form. The ball follows the optimal arc to the basket. Now with reverse practice, you would deliberately practice missing. Shoot too far left, too far right, too short, too long. By experiencing what it feels like to miss in different ways, your motor system builds a more complete map of the error space surrounding the correct movement. Research on reverse practice in basketball has shown improvements of 20 to 30% in free throw accuracy compared to traditional practice alone. Another powerful example comes from music. Let's consider a pianist learning a complex passage. Imagine playing a specific note correctly. This is the target that traditional practice focuses on. With reverse practice, you would deliberately play the wrong notes. Play 1/2 step sharp, 1/2 step flat, play with wrong timing, play with exaggerated dynamics. What happens is that your auditory system becomes much more sensitive to pitch deviations. You're training your brain to hear the difference between right and wrong with greater precision. We can model this mathematically with what I call the error sensitivity function. S of E equals K times E to the power of negative lambda times the absolute value of E. S is the sensitivity to error, E is the magnitude of the error, K is a scaling constant, and lambda determines how rapidly sensitivity increases with practice. As you practice, lambda increases, meaning your sensitivity curve becomes steeper. You become better at detecting even tiny errors. The key finding is that reverse practice increases lambda much faster than normal practice. By exploring the error space, you're essentially training your discrimination ability. Let's look at a medical example. Surgical residents learning to perform precise incisions. The target is a perfectly controlled incision. Traditional training focuses on getting this right every time. With reverse practice on surgical simulators, residents deliberately make errors. Cut too shallow, cut too deep, cut at wrong angles. The result is faster development of proprioceptive precision. They develop a kinesthetic sense of exactly how much pressure and what angle produces the desired result. Studies have shown up to a 40% reduction in training time to reach proficiency when reverse practice is incorporated. Now let's talk about cognitive error detection. This applies to problem solving and mental tasks, not just motor skills. The anterior cingulate cortex is a brain region that monitors for conflicts and errors in cognitive tasks. It's like an alarm system that says something's wrong. When the ACC detects an error, it sends a signal to the prefrontal cortex, which then adjusts the cognitive strategy. Consider learning programming. Traditional practice involves writing correct code and fixing bugs when they occur. Reverse practice means deliberately writing buggy code. Introduce off-by-one errors, reverse logic operators, swap variable names. What this does is train your pattern recognition system to immediately spot common error patterns. You become much faster at debugging. There's a hypothesis in motor learning research called the error space exploration hypothesis. Let me explain it. The idea is that true mastery isn't just hitting the target. It's mapping the entire space around the target, understanding the gradients of error in all directions. Here's a visual representation. The green dot is optimal performance. The red dots represent deliberate errors in different directions. By practicing these errors, you map the error space. Traditional practice tends to cluster around the center, around optimal performance. You don't explore the boundaries. Reverse practice systematically explores the boundaries. This gives you a complete understanding of the performance landscape. Let's try to quantify the learning benefit of reverse practice with some numbers. Time to mastery equals n divided by alpha effective. N is the number of parameters to learn, and alpha effective is the effective learning rate. With traditional practice, let's say your effective learning rate alpha is about 0.1 per practice session. With reverse practice incorporated, studies suggest alpha can increase to about 0.15 per session. That's a 50% increase in learning rate. The ratio of traditional time to reverse practice time is 0.15 over 0.1, which equals 1.5. This means reverse practice can cut your training time by about 33%. Let's look at an example from language learning. Pronunciation is a perfect domain for reverse practice. When learning difficult phonemes in a new language, traditional practice focuses on repeating the correct sound until you get it right. Reverse practice means deliberately exaggerating wrong pronunciations. If you're learning the French R sound, practice the English R, practice an overly guttural sound, practice it too far forward. What happens is you create a contrast space that sharpens your auditory and motor discrimination. You understand the boundaries of correct pronunciation. Research on language learning shows about 25% faster phoneme acquisition when reverse practice is used compared to traditional methods. There's another hypothesis called the neural efficiency hypothesis that helps explain why reverse practice works. Brain imaging studies show that expert performance actually shows less overall brain activation than novice performance. Experts are more efficient. Reverse practice appears to accelerate the pruning process. By experiencing errors, your brain more quickly eliminates unnecessary neural pathways and strengthens the essential ones. Neural efficiency E equals performance P divided by activation A. Higher E means more efficient processing. Studies using functional MRI show that reverse practice increases neural efficiency E faster than traditional practice methods. Now let's talk about how to actually implement reverse practice. There are some important guidelines. The optimal ratio appears to be about 70 to 80% practicing correctly and 20 to 30% practicing deliberate errors. If you go beyond 30% error practice, you risk reinforcing bad habits. The errors need to be deliberate and conscious. A critical principle is to always explicitly label the errors in your mind. Say to yourself, this is wrong, this is what I'm avoiding. This prevents accidental learning of the error. The errors should be systematic explorations, not random mistakes. You're deliberately testing the boundaries, not just being careless. There's a fundamental principle at work here called the contrast principle. The brain fundamentally learns through comparison and contrast. You understand light because you've experienced darkness. You understand quiet because you've experienced noise. Reverse practice provides maximal contrast between correct and incorrect performance. This contrast is what drives learning. Learning L equals K times the logarithm of S correct divided by S error. S correct is the signal strength of correct performance, and S error is the signal strength of errors. To maximize learning, you need both a strong correct signal and sufficient experience with errors to create contrast. Reverse practice achieves this. Let me address some implications and questions about reverse practice. First question, Does reverse practice work for everyone? The research suggests it works best for individuals who already have some basic competence in the skill. Complete beginners may need to establish a basic foundation before incorporating reverse practice. You need to know what correct feels like before you can deliberately explore errors. Second question, what about mental blocks and fear of failure? This is important. Interestingly, deliberately practicing errors can actually reduce fear of failure. When you make mistakes on purpose, you realize they're not catastrophic. This can improve performance under pressure. Third question, are there domains where reverse practice doesn't work well? In high-risk domains like surgery on actual patients or flying actual aircraft, you can't practice errors directly. That's why simulators are so valuable for implementing reverse practice safely. There's also a meta-learning benefit to reverse practice that's worth discussing. When you practice errors deliberately, you're not just learning the specific skill, you're learning how to learn. You're developing a more sophisticated understanding of the learning process. This metacognitive awareness transfers to other skills. Once you understand the power of exploring error space in one domain, you can apply it to others. Let me summarize the key takeaways about reverse practice. First, deliberately practicing errors strengthens your brain's error detection circuits through enhanced synaptic plasticity. Second, the optimal ratio is about 70 to 80% correct practice and 20 to 30% deliberate error practice. Third, always explicitly label errors in your mind to prevent accidentally reinforcing them. The errors must be conscious and deliberate. Fourth, the learning benefit ranges from 25 to 40% improvement in acquisition speed across various domains. Fifth, the mechanism works through systematic exploration of error space and creating contrast between correct and incorrect performance. Finally, reverse practice works best for learners who already have basic competence and are working toward mastery.